Hey Space Friend. I thought I was committed to that LCD that I found, but then this beautiful LED dot matrix came into my life, and I just can't help but play favorites. So let's figure out how it works. There are many types of matrix displays in different sizes and with different types of pins. They commonly use an integrated circuit called MAX7219, which is a serial input-output common cathode display driver that you can use to connect a microprocessor to various types of LED displays. Many matrices come without the driver, so if you purchase the display and the driver separately, you'll just need to connect them together. Today I'm using this 4-in-1 module with the driver already attached because it's simple to use and only has 5 pins. For a simple 8x8 square matrix, there are 8 columns and 8 rows, indexed 0 to 7. To display something, you just need to know which element in the row or column is turned on or off. A small 8x8 matrix has 64 LEDs, but we can get around needing 64 data pins by using LED multiplexing. With this, all cathodes are connected together in the rows and all anodes are connected together in the columns. Each column is briefly activated to turn on the necessary LED for that row. In a multiplex array of LEDs like this, only one row is actually on at a time. The reason we can view a full image is because the Arduino is switching through the rows hundreds of times a second, so we're not even able to perceive which rows are actually flashing on or off. The two common types of displays are the generic 8x8 module and the FC16 module, which is just 4 8x8 matrices side by side. The pins are the same, but the code will vary slightly depending on which type you have. There are 5 pins on each side, 1 for input and 1 for output. The input side takes instructions from the Arduino and the output side connects to other display modules. The input pins are VCC, ground, DIN or data in, CS or chip select, and CLK or clock. This type of display uses the SPI communication protocol. Data in is the MOSI pin. This is the line where data is sent from the Arduino to the display. The clock pin is the clock line that synchronizes the output of data bits. And the chip select pin is where the main device selects which peripheral device to talk to. There's a few libraries that we'll need to include with this display. The first is the MD-MAX72XX library. This is a device control library that implements functions to control LED matrices using drivers like the MAX7219. The second is the MD Parola library, which was designed to work with the MAX72XX library. It includes lots of special effects for the text display. You can find both of these by going to Sketch, Include Libraries, Manage Libraries, and searching for the name. If for some reason it doesn't come up for you here, they're also available to download online. Finally, we need the SPI library, which is already included with Arduino, so you don't need to manually install it. All we need today is the matrix display and 5 male to female jumper wires. Connect VCC to 5V, ground to ground, CS to 10, DIN to 11, and clock to 13. First, let's just print out some text. The first step is to include our 3 libraries and define the hardware type. This is where it matters which type of device that you have. The generic 8x8 module has a green board and the FC16 has a blue board. If you're using the 8x8, use generic_HW as your hardware type. If you're extra like me and using this larger 32x8, then use this FC16_HW as your hardware type. Next, we define the max number of displays that we're using with max devices. One MAX7219 IC controls a single 8x8 module, so that just counts as one device. So if you're using an 8x8, then put 1 for this number. And if you're using this 32x8, then put 4. We then set our pin numbers, but depending on if you're using hardware or software SPI, some of these won't need to be used. SPI protocol requires precise handling of the SPI device pins. The Arduino's specialized SPI pins when you're using the SPI library are pins 10 through 13. Using these means that the Arduino is using a dedicated piece of built-in hardware to control the SPI protocol just in the background. Whereas with software SPI, you use some sort of software layer to do all the work of handling the protocol. It doesn't matter too much on a small device like this, but hardware SPI is a lot faster than software SPI. It also is pretty simple since it's already built in, so we're going to do hardware SPI with this code. If you wanted to use software SPI, you would need to specify all the pins like this instead. I'm using hardware SPI, so when we create our display object using MD Parola matrix, we only need to include the hardware type that we defined at the beginning, the chip select pin, and the max devices we defined. The way we're doing it here, you could delete or comment out the data pin and the clock pin variables and it would run just the same. So this MD Parola matrix that we are setting all of that to, the MD Parola part is creating an object to reference our physical matrix. And then matrix is just the name that I personally gave to this object. In void setup, begin initializes the display like how we used init to initialize the LCD. The brightness is set with set intensity and can be between 0 and 15, with 15 being the brightest. I left mine at 0 because it's playing bright enough without risking any damage to it. Display clear ensures that the display is going to be blank at every startup. Set text alignment simply specifies where we want our text to be aligned, so I'm putting it in the center, and then matrix.print is just what we want to print out. And I'm printing space. Now let's use the MD Parola library to see some different ways that we can do special effects for the text. We need to do the same setup as before, but also create this int I equals 0 variable because we're going to use that in the loop later. Then we're making an array called text effect. We're tying that to text effect underscore t, which is used to define the effects to be used for the entry and exit of text in the display area. This creates an array of various effects that we can pull from later in the code. All of the items that are in this array, the PA wipe cursor, these are all things that are taken directly from the Parola library. The two new functions in void setup are set speed and set pause. Both of these take a speed parameter, which is the time in milliseconds. The speed is the time between animation frames. The lower the speed, the faster the animation. Set pause pauses by the number in the parentheses between each text entry and exit. For continuous scrolling, pause can be set to the same value as the speed. Down to the loop, display animate is a Boolean function. This animates all the zones in the display using the currently specified text and animation parameters. So this very first if statement means if display animate is true, so is it animated, then continue to the next if statement. And then if I is less than the size of the text effect array, then increase I incrementally by 1. This syntax is really common for looping through things. In this case, the text effect array that we created. So the program is just going to continuously loop up to the size of the array. If the display is not animated, then I stays at 0 and nothing happens. After that, matrix.displayText is within that if statement, so that's going to happen next. This function is for static text displays. The parameters are ptext align, speed, pause, effect in, and effect out. Ptext is just what we want to print. To get the alignment, speed, and pause, we are using get alignment, get speed, get pause to pull from where we already set those up in the setup. So set text alignment center, set speed 100, set pause 1000, get speed, and get pause, they just pull directly from there. For effect in and effect out, we're using that value I for the text effect array again. Then we reset the display and return to the beginning until we unplug the Arduino. So to break this down a little bit more, let's go through the first iteration of the loop. The display is now on, so display animate is true, we can move to the next if statement. I is currently 0, so the second if statement is true as well. 0 is less than the size of the array. Now we have 22 elements in the array, but arrays start at index 0, so they're numbered 0 to 21. PA wipe is at index 0, and then PA scroll down left would be at index 21. Since the index starts at 0, using I++ is now going to make that value 1. So when we get down to matrix.displayText and we have those last two text effects with I in the brackets, the value of I is now 1. So the second element in the array. The second element in the array is PA wipe cursor, so that's going to be the first effect that happens when we first turn the display on. Then the loop starts over and just iterates to that array continuously until we unplug the device. I want my text to scroll with the message, "This is legitimate salvage," in case anybody tries to accuse me of not being the true owner of this ship. So here's the code to just achieve a simple scrolling message. I went ahead and took out the data pin and clock pin just to show you that we really don't need those for hardware SPI. Then in the setup, display scroll has got 4 parameters, the text alignment, effect, and speed. So I have initially entered my legitimacy proclamation string. Center alignment, the effect of scrolling to the left and at a speed of 100 milliseconds. The code in void loop is going to reset the display so that what we entered in the setup will just continuously scroll. Well, I don't know about you, space friend, but I am on high alert for fellow space pirates who may want to take our completely legally owned ships from us. But now that we've got this nice bright signage declaring our legitimacy, I think we're going to be totally fine.